Hey everyone, my name is Eric Escobar, and today we're going to be talking about how to hack laser tag. So this is going to be a DEF CON talk just as if I were in front of you giving a live presentation, but since so many people are remote, we're pre-recording this ahead of time to be posted on YouTube. So really the way that this talk works is that there's nothing really security minded about it. This is just for fun. This is not a 0 day in some crazy platform. But my hope is that you'll see my design process and maybe this will be of interest to somebody out there. So really when when I thought about doing this, I think everybody asked me, okay, why are you going to invest so much time in trying to hack laser tag? And really, it's a David and Goliath story. And what it comes down to is the local laser tag place that we have here in town. They have kind of a reward system where you can buy points, buy better guns, and leverage all of that to do better in an in-game scenario. So you can upgrade your weapons and go from there. Well, inherently, having played laser tag, as a kid and then growing up, this system seems inherently unfair in that somebody can just buy their way to being a really good player. So I went one night with my cousin and just got smoked. Right, there was a team of like I think college students that came and played regularly, so they had all the power ups, all the boosts, all the shields, you name it. And so I thought, you know what, let's kind of inspect this and take a look a little bit deeper at what's going on under the hood and see, hey, maybe there's some way, something that we can do to give us an advantage and really an unfair advantage. So what did I do? Well, I basically applied some engineering thought process through it and did a lot of Googling. So let's start this off with talking about how laser tag actually works. Really, a lot of people think that it's using actual beams that are actual lasers, but in reality, it's just a narrowly focused beam of infrared light. And so really, it's just a less fancy version of your television remote that you're using, and it uses infrared light to transmit a signal, just like when you press the power button on your remote, and that signal is actually counted as a shot from a tagger or your laser tag gun. So again, the technology underlying it is exactly the same. There's just a lot less different buttons and options typically on the laser taggers. Now, so what is infrared light? You're probably wondering. Well, it's not visible light, as you can see. It's on the right side of that spectrum, and it's typically not visible to the naked eye. Now, maybe you've seen a security camera at night, and you'll see that really deep, low glow red. That's typically infrared light, and that's what's used in these laser tag guns. So you're not going to actually see beams or flashes. And if you do see beams or flashes, those are typically added on lights that show some type of trigger, some kind of spotting, so that you can aim. But they're not actually used in game. And so if you actually had a kind of a crummy camera, or maybe some older version of a camera that doesn't have an infrared filter, you can actually point a camera at a remote, at a laser tag gun, and press the button. When you press that button, you'll see that flash of purple light come across, and that's basically your camera picking it up on the sensor and not really using it in such a way that your eyes could see it, but that the sensor picks it up. And this is just a quick demonstration of how that looks. So now talking about how the game itself and how all that jazz works, you have your vest typically, or it might be a headband or whatever your flavor of local laser tag is. And essentially these lights are basically just set up as targets, but really that's the receiver piece of it, that when you shoot the infrared light at any of one of those spots, you'll be then able to see, or that vest will then transmit that message back to the game server. And there's a lot of different ways that this can work in terms of, sometimes the taggers, the guns themselves will also have, receivers on them. Again, but really the main thing that I'm trying to get at here is that the vests themselves are the receiving piece of it, and the taggers are the sending piece of it. And so to go back to my previous example of it, you can think of the vest as your TV, and you can think of the laser tag gun as a remote. And so you're sending the signal, and if that signal is to hit a receiving spot on your vest, then that's going to trigger as if you've been tagged. And so really, here's what it all boils down to: is you have on the left-hand side is a little infrared LED, and on the right-hand side you have a receiver. And it's really just these two components in tandem that are allowing you that communication. And what's kind of cool about that is that this technology is actually super cheap, and readily available all over the internet with tons of documentation if you just do a little bit of Googling. And so when you do get tagged, like I mentioned before, you'll see that there'll be some other typically back-end technology. Maybe it's Zigbee, maybe it's some other type of Bluetooth, maybe even Wi-Fi that'll transmit back to the game server. And the game server is responsible for saying, what type of shot was it? Did it come from a different type of tagger? Were you on the same team? Was it for perhaps maybe a respawn frequency? So the game server is actually what does all the logic and all the back end programming and all the back end distribution of how the game actually works itself. But really, what we're focusing on here, going back to this other slide, is not hacking the actual game, server, the actual game setup. We're hacking the signals that are being transmitted to the vest. And so this infrared, it's one-way communication, right? And the same code is repeated over and over and over again. So just as if you were to hit the one button on your remote, it's that same signal that's used over and over and over again. Now, if you're familiar at all with wireless security, or maybe even just computer security in general, this is just a replay attack, to where if you have a way of capturing that code, if you're able to transmit it over and over and over, the vest in the game server has no way of differentiating, essentially. It has no way of differentiating whether or not it came from a legitimate gun or if it came from, a clone gun. And really, the funny part about that is, I really wouldn't expect it to. At the end of the day, this is just a fun little kids game. And why would a hacker stoop to this level and apply this much effort? And for me, it's really fun, and I really like the challenge. But again, I don't really expect that there would be two-way communication or a checksum or rolling code or anything like that. I think that's really kind of beyond the scope of the security of just a simple laser tag game. So my inspiration, if you Google around on the internet, was this bird laser tag cheating device. And essentially, this is a really stripped down version of what I wanted to do. And all it does is it receives and then retransmits on a single IR LED, and it just uses a 9-volt battery. Now, the awesome part about this device is that it's super small. As you can see, it's just basically the size of that 9-volt battery. And so I kind of wanted to make my laser tag cheating device, my I guess creation, to have a little bit more features and a little bit more expandability than just a simple replay attack. So in order to do this, instead of using like a ESP3266, I decided, 8260. Anyways, I can't remember the version of that ESP. But instead of using an ESP, I decided, hey, I can use bigger functionality with a Raspberry Pi Zero W. It's pretty darn small. You can see it in somebody's hand. You can see that it has Wi-Fi on board. And then I can host a web server and do a ton of other stuff. And that is a technical term. And I wanted to take this to the extreme. I wanted this to be, grotesque in how many people I could take out all at a given point in time. So I wanted it to have multiple LEDs. I wanted it to be really high power. I wanted it to have a simple user interface that I could just interact with on my phone. And I also wanted to have data logging. And data logging, might seem kind of strange, but it would be really interesting if you wanted to use this device to pull some data back later and then see, is there a predictable way that you can see different codes mean different things, perhaps. Other design considerations, obviously this device has to be concealable. You can't just walk in with your own completely 3D printed gun. This has to be something that you could place under the gun, over the gun, or hold in kind of a discreet manner. It had to be easy to use because, again, if you're in the midst of combat, you don't want to have to be fiddling around with a bunch of wires and resistors and all that jazz. I also wanted these LEDs to be ultra bright. I wanted them to be widespread, and I wanted them to be spotted, or I wanted them to be able to tag a vest all the way across, an arena. And also, I wanted to have decent power so I could play, a whole host of games, and not have to worry about recharging the device over and over and over again. So I decided to get the largest, most powerful IR LEDs that I could really reasonably find, and so I got these off of Adafruit, and they can do, I believe, 1 amp pulses, so you can't use that 1 amp continuously, but for a pulse, it works really well. And also has a 20-degree cone, so you can think that basically the tip of it irradiates at a 20-degree pattern, which is actually quite large when you get any measurable distance away from it. And so that was the LED that I chose. And then I decided, okay, I want a lot of them all spread out. And so I decided I want some 5 degrees worth of overlap, and it'll give me 70 degrees of total spread. And in actual testing, the spread is much wider than 70 degrees. It's anywhere between 120, 180 degrees. But again, that's just from the manufacturer's spec that I got that 70 degrees total spread. But again, 70 degrees pointed at a room is far greater than most flashlights. So when you think about me having a laser gun or a tagger, instead of it just targeting a specific person with a narrow beam, this can basically cover everybody in an entire room all at once. So it's totally unnecessary, and it's going to mean gratuitous, tagging of individuals. So here is my 3D printed model of what that looks like. And the nice part, and the reason why I decided to 3D print it, is because I could get those, it was easy to do that offset and do all the angles properly and 3D print it out, instead of me trying to drill or do this all by hand. Then I had to create a box, and with all of my 3D prints and all of my designs, it starts off with like, oh, how hard could this be? This is just going to be a simple little box. And then you start having to take into account ports and holes and screws and mounting points, and it gets a lot more complicated, a lot faster. And I just used Tinkercad. It's just it's a pretty easy, simple to use web-based CAD program that you can export to STLs and then 3D print from there. So as you can see, there's the front piece of it. Then I have the supports, how basically the devices mount into the base of it, and then how the top and the lid fastens to it. If I could do anything over again, and if I had more time, I probably would have made a thicker box just to give it more rigidity, but it actually works pretty darn well for what it is anyways. So power management, I wanted to be able, obviously, to power the Raspberry Pi and the LEDs, and then all the different types of converters. And so I settled on using an Adafruit Power Boost with a 250 milliamp hour battery. And that battery is definitely enough to last me at least an hour or two running the Raspberry Pi and the access point and everything full tilt. And so basically the way that this works, and what also makes this kind of nice too, is that I can power the device off of this battery and then also charge it at the same time. So it kind of works how your cell phone does, in that you can plug it, unplug it, and it's like it's an uninterrupted power supply UPS. So you can just charge it in between games, charge it in your car, wherever, and you don't have to worry about it shutting off the Raspberry Pi every single time you unplug it from power. Now, I calculated out to have 30 minutes of juice, but again, I can get probably 1 to 2 hours out of it, no problem, depending on how much it's doing on the back end. So that's pretty darn good for the size of this little battery. So now powering the LEDs, this was more of a tricky problem than I thought it was going to be. So I hooked up this buck converter because it's pretty darn efficient to step it down from 3.3 volts to 1.2 volts. The buck converter makes everything a lot more efficient than if you're just trying to do some type of resistance that's going to generate a lot of heat. And this also shout out to one of my coworkers. I don't know if he wants his name mentioned, but you know who you are, and you really helped me out a lot. He's an electrical engineer, and he definitely was like, "Oh, dude, you're doing this all wrong." And so he gave me the idea of that buck converter. Now, talking about connectivity, I wanted all the commands to be run in the background. I wanted all this to be done on my phone. That way I wasn't trying to get into fiddle with buttons or dip switches or anything like that. And so I could have done this in 2 different ways. Either I can have a hotspot in my pocket, or I can stand up an access point on the Raspberry Pi Zero itself. So depending on whatever the configuration was, I can do either one of those. I typically like to have it connected to the hotspot. I found that was a little bit more reliable than trying to stand up an AP on the Raspberry Pi Zero itself. So here's some pictures of it. I'll talk through some of the different things you can see. You can see the buck converter to the bottom left. You can see how all the LEDs are all wired in together and how those solder onto the buck converter. Then in the back, you can see that the battery charger for the battery, and then the Raspberry Pi Zero W with a 32 gig card. You don't need the 32 gig card. That was just what I had on hand. And then you also can see all the different wires that interface with the the little MOSFET that's in there to switch on the power for the LEDs. Then I built up the box, as you can see, just basically make it more rigid, making it so that it was, battle hardened. Not the best soldering job on the wiring, but it worked out really well. And then I basically sealed it all in with hot glue so that nothing shorted out on me while I was in game. This is the device powered on. Again, it's powered by USB, so you can power it by straight USB. But that when you power it off of the USB, it also uses the extra juice to charge the battery too, which is really nice because, like I said, in between games, you can easily just plug this in, to like just a standard USB rechargeable thing, whether that's like from your cigarette lighter, phone charger, external battery, whatever it may be. Which I didn't really think was going to be as useful as it was, but man, it really helped for playing over and over. So the software, I am not a programmer or developer. I'm a hacker, so I really don't have any idea what I'm doing. But I figured, hey, this doesn't, like like all terrible design considerations, this isn't ever going to be seen by the public. This is just going to be on a single hotspot connection. So again, this is hacked together code. I have no idea what I'm doing. So if you use this, buyer or user beware. Then I use Pi GPIO-D for all the receiving and transmitting on the Raspberry Pi pins. And then I used a script that I found, I think I've credited in here, IRRPi, to send all of the RxTX to an actual file itself. And that goes back to kind of my data logging capability. So this is basically how that. Oh yeah, I did. Here's this tool that somebody just posted on the Raspberry Pi forums. So you can see you can record, you can play, you can look at the different frequencies that are available if you have maybe a different type of game. And so this tool is really kind of a full feature set that I put a web front end on to use. And so kind of here's how the user interface flows. So you name the signal, and then you start listening to the signal, and that's where you would then shoot your gun into this. So if you think about this in like a game situation, you start up your device, you name it, so when you record it has something to go to, and you shoot the gun into it, and then it says, okay, I've remembered this frequency is what your blaster is, perhaps. And so then I repeat it again. I basically shoot into the gun again, or I shoot the tagger into the device again. Basically, this is just to make sure that I got the proper signal, and basically just does a check, kind of like typing in your password twice, just to make sure you have the right one. And then it saves it to a file on the Pi. So what's cool about this is that you can clone multiple guns for multiple games, or if there's some fancy laser tag arenas also have other devices that produce IR signals. So you can think of like maybe a respawn point that will allow you back in. You could say use that so you could also be a medic for your team, or if there's a better gun or a device that a bomb that's supposed to go off, you can clone all of these different devices and save them all to a file on the Raspberry Pi that you can replay later, or you can inspect later on when you get back home. And so then from there you can select the signal that you want to transmit, and then when you tap fire, it will just run that command in the background, and you can set how fast you want that rate to fire, but the default is 20 rounds a second. Now, if you're thinking of a standard laser tag game, you can typically get maybe 1 or 2 rounds off a second, and again, that's a narrow focus beam, whereas this is going to tag anybody in the vicinity. And typically for a laser tag game, you have maybe 3-4 hits will be somebody gets tagged out. So you figure 20 rounds a second, and in a second you can take out an entire wall or entire room or swath of people. So really, I don't need to go any faster than 20 rounds a second, which is pretty darn fast, even if you just have a quote unquote standard gun that is not high powered. So let's see if this is going to pull up. This is kind of a recording of the workflow. Again, as you can tell, I am not a web developer, so everything is just flat font. It is just just links, and it's not the most pretty thing. I'm not worried about encryption or command injections or anything else like that, because again, this is just over my own private WPA2 network, which somebody would have to then compromise that WPA2 randomly generated passphrase. So I'm not super worried. And so basically you'll see this screen that will show up of, hey, it's firing, and then only until you click the ceasefire will it then stop firing. So you could just know that device is just pulsing out 20 times a second that signal. So how did it work? Well, funny story on how it all goes. So you build your creations, you build this device, and then you always have to go test it in the field. And you always wonder, man, is it just not going to work at all? Is it going to fail spectacularly? Am I going to get caught, by the laser tag arena scorekeepers? What's that going to look like? So I took my cousin, to go play laser tag, and there was again those college students that had all these powered up guns, and so I said, okay, I'm like, well, we'll see how this works. And so we clone a gun, and it absolutely wipes out everybody the second that we get it out there. So much so that we basically had, we were trying to dissuade suspicion, but again, it worked out really well. And the other thing that was also really kind of fun about this that I didn't take into account really when I made it is that if you were to clone the healing frequency, you can basically just heal everybody on your team. You can basically respawn everybody on your team and just kind of hang back there. So if you hang back, you can just basically make it so that no one on your team ever dies. Which again, this is all completely cheating. This is completely below the belt, underhanded. But again, it's a really just kind of fun way to see how design considerations in off-the-shelf products can lead to unintended consequences, or engineers taking it way too far and using their powers, for some jokingly nefarious actions. So yeah, I hope everybody enjoyed it. If you ever have any questions about it, feel free to hit me up on Twitter. I'm always pretty darn available. And yeah, I thought this was really fun, and I thought it'd be something kind of cool to share. So anyways, hope you're all doing well and enjoy DEF CON.